Okay, so we're gonna just look at actually just example 2 today, and the reason for that is I want you to really sort of get a picture on when you should use the quadratic formula, because you definitely should not always use it unless you love it, but you probably don't. Okay, so this says solve this equation using two different methods. Which do you prefer and why? So I'm actually going to show you all three methods that you know at this point. So those methods would be factoring, graphing, and quadratic formula. Those are all ways to solve problems that have real solutions. If they have imaginary solutions, you're kind of stuck with just quadratic formula. So we'll see how this goes. So let's go ahead and just start with seeing if we can factor this. So in this case, there's no GCF, so we go right to AC factoring. And our AC, 6 times negative 1 or negative 20 is negative 120. And if we want to find the factors of negative 120 that add to negative 7, we'll go to our old calculator here and try to find something. So if I'm looking for a pair that adds to 7, oh, this looks like a winner here. So if I use 8 and negative 15, yep, okay. So 8 times negative 15. All right, so we're going to do our grouping factoring here. Again, hopefully you don't forget all this stuff because it kind of never goes away. So all these things that we've learned, and that's one of the nice, I don't know, maybe you don't think it's nice. One of the things about Algebra 2 is it just snowballs throughout the entire year. It just keeps building and building and building. So you got to keep all your skills kind of available. All right, so we pull GCFs out of these. So this looks like a 2x we can get out of that. Leaves you with 3x and plus 4. Okay. Take a negative 5 out of those. Leaves you with 3x and plus 4. Looking good. All right, so our factors are 2x minus 5 and 3x plus 4. Okay, so hopefully you didn't forget that. Again, that's a skill that we definitely did a ton of back in section 2.3. From here, what are the solutions? Well, it's whatever makes these parts equal 0. If you remember, the shortcut is it's the opposite of this over the coefficient. So it's going to be 5 over 2. So 5 halves is going to be one solution, and opposite of this, so negative 4 over 3 is going to be the other. Okay, so boom, we know our two answers. So if you like them as fractions, that's 2.5 and that's negative 1.33. If you like them as, decimals, fractions, whatever. So that works. That's factoring. You also have graphing. In my opinion, you're probably going to like graphing the best because you can use the calculator or decimals either way. And you throw the equation in and you go look at the graph and you look for the intersection points. So on this, oops, not the table, we should see these two exact spots. So just visually, these make sense. Remember how this is like negative 1.33? That looks pretty good. This is 2.5. That looks good. But again, you can just get them from here too. So if you go to second calc, you want to find when the graph is 0. And this is your left bound, right bound guess. Boom, there's that first one we talked about. Sorry, a little glare. Negative 1.33, that's that number there. And we just repeat the same steps over in the other spot. And again, if you use the decimals app, it's even easier. You literally just click on the spot and it gives you the coordinate. So, use that if you want. And then 2.5, that's our other one. So those are the two methods you should already be pretty familiar with. Factoring, graphing. Now, I would personally never use quadratic formula on this problem because these methods both work. And in my opinion, these methods are both faster. But maybe you don't like these methods. Maybe it's the no calculator portion of the SAT, so you can't use this. And maybe it's you just can't figure this out, or you forgot how to factor it. So you're like, I'll just do quadratic formula. So I do want to show you that it also works basically to kind of connect all three of these, and you see they do all do the same thing. So here, if we do opposite of b, so that's 7 plus or minus b squared minus 4ac all over 2a. Okay. So what do we have? 49. This is going to be a plus, but some big number. So what do we got? 4 times 6 times 20 is 480 over 12. Now, the one nice thing that does happen here is that the number you get there does end up being a perfect square. So you have 7 plus or minus the root of 529. But 529 the square root of 529 is actually just 23. So we really get 7 plus or minus 23 over 12. And this is where you're going to see how this turns into these answers. is when you do 7 plus 23, and I'll just do it to show you here. So 7 plus 23, and then you divide it by 12, boom, there's that 2.5 or that 5/2 answer. So you get 2.5 as one answer. And if you do it the other way, where you subtract, 7 minus 23 and divide that by 12, there is the negative 1.3 repeating answer. So the connection you want to make here is that all these methods work. They all do the same thing. Factoring, graphing on the calculator, doing the quadratic formula, all three gave us the same solution. So they all work. And on problems like this, there's going to be problems where you can just choose to do any way you want, and that's what the whole idea with these are. Okay, so let's approach this second problem as, what would I do? Like if I saw this problem on a, if I'm given this problem, let's say we're taking the SAT, we have our calculator, and I'm like, all right, I see this, what am I going to do? Honestly, the first thing I always do is graph it, because I think that's just the fastest, quickest way, especially when A is not 1. If A was 1, I might just try to factor it right away, because I feel like I can factor pretty quick. But right here, I'm going to be like, all right, I'm just going to graph this and see what I'm working with. And then from there, I'll go and do what I can do from there. So this is what I would do. 6x squared plus x plus, or minus 15. And then I'm going to go look at the graph. And I see it's got two real solutions. Good. Let's go ahead and figure out where they're at. So I've got a 0 over here at negative 1.6 repeating. So negative 1.6 repeating is also known as negative 5/3. So I'm going to write my answers as fractions, just because. And then my other one, boom, 1.5. Perfect. So 1.5, also known as 3/2. Again, you can write the decimals too. Now, this is what I'd be done at this point. These were both nice, clean fractions. I was able to just get the exact answers and be done. Now, what if they weren't? So what if these were big, nasty decimals that went on forever that didn't have a fraction? If they were your rational numbers. If that's the case, then I need to do the quadratic formula to get one of those simplified roots like we talked about in the last unit. Where you're getting these types of answers where you have something under a root. So that's kind of what you should be looking at when you're doing these problems, is if you get a messy decimal out of that, that's your indicator that you need to do quadratic formula to get the exact value. And that's really it. That's what we're going to practice today. So today you're going to get problems, and you can kind of go through your little flow chart there of how you want to solve them. Can you graph it? Can you factor it? Do you have to do the quadratic formula? And so that's what you're going to see in the assignment today.